Welcome to The Explainer. You ever look at a map and wonder why a huge city is right where it is? Or why that small town just happens to be a few miles down the road? You know, it might seem totally random, just a result of history. But what if there's a hidden, almost geometric logic to it all? Well, today, we're diving into central place theory, this really powerful idea that uncovers the invisible order shaping our entire world.
So here's our game plan. We're going to start with the basic puzzle. Why are cities located where they are? Then we'll get into Walter Christaller's brilliant hexagonal solution, check out its 3 key principles, and see how a later update made it even more realistic. And to wrap it all up, we'll look at why this theory, which is almost 100 years old, is still incredibly relevant today.
All right, let's start by framing the core question that geographers were obsessed with for decades.
I mean, really think about it. Why does a giant metropolis pop up in one spot, a medium-sized town over there, and a tiny little village just a short drive away? At first glance, it just looks like chaos, right? But central place theory says, nope, it's all part of a surprisingly predictable system.
So, the first really elegant solution to this whole puzzle came from a German geographer named Walter Christaller way back in 1933. Christaller's genius was that he started simple. He said, okay, let's just imagine a perfectly flat, endless plain. No mountains, no rivers, nothing to get in the way. On this ideal landscape, he argued that the main reason any settlement even exists is to be a central place, basically a hub for providing goods and services to everybody living around it.
And that's the first key idea you need to get, the central place. A big city is a central place for an entire state or region, while a small town is just a central place for the little villages nearby. It's all about being a hub.
Okay, next up is the threshold. This is just the minimum number of customers a business needs to actually stay in business. Think about it. A little convenience store has a really low threshold. It doesn't need a huge population. But what about a hospital that does specialized brain surgery? Or a huge university? They have an incredibly high threshold. And that's exactly why you only find them in big cities.
And finally, there's the range. This is simply how far you're willing to travel for something. For a gallon of milk, maybe a few blocks. That's a low-range good. But for a specific kind of car or to go to a top-tier university, you might travel for hours, right? That's a high-range service. It's the constant tug-of-war between this range and the threshold that literally creates the entire system of settlements, from the smallest hamlet to the biggest megacity.
So this all leads to the theory's most famous, most iconic feature. If every business's market area was a circle, you'd have a big problem. You'd either have weird, unserved gaps between the circles, or they'd overlap, which is just inefficient. Christaller's big aha moment was realizing that hexagons are the most perfect, efficient shape to tile a surface with 0 gaps and no overlap.
And you can see right here how it all clicks together. Just look at this diagram. It's this beautifully nested hierarchy. The market areas of the smallest villages fit perfectly inside the hexagons of the bigger towns, and all of those are nested inside the giant market area of the main city in the center. It's this perfectly ordered geometric vision of our urban world. Pretty cool, right? Now, here's where it gets really, really interesting. Christaller didn't just say there's one single pattern. He knew that depending on what a society cares about most, whether it's shopping or transportation or just good old-fashioned government, different geometric patterns would pop up.
And he defined these patterns with something called a k-value. Now, don't let the term scare you. It's simple. The k-value just tells us how many smaller towns are served by the next biggest city. He came up with 3 main systems, each with its own logic and its own k-value: the marketing, the transport, and the administrative principles.
First, we've got the marketing principle, which is k equals 3. You can see it in this top diagram. The whole point here is to make it as easy as possible for people to shop. The smaller towns are right at the corners of the hexagon, so they're shared between 3 bigger centers. This means a big city serves itself plus 1/3 of the people from each of its 6 neighbors. Add it all up, and you get a k-value of 3. Next, take a look at the middle diagram. This is the transport principle, or k equals 4. In this world, getting from point A to point B as cheaply and quickly as possible is all that matters. So the smaller towns are located right on the most direct travel routes between the big cities, smack in the middle of the hexagon's sides. Here, a big city serves itself plus half the people from its 6 neighbors, giving us a k-value of 4. And finally, the bottom diagram shows us the administrative principle, or k equals 7. This one is all about politics and control. You don't want any confusion about who's in charge of what, so all 6 of the smaller towns and their entire market areas are contained completely inside the big city's hexagon. The central city governs itself and all 6 of its neighbors. It's a clean hierarchy, giving us a k-value of 7.
But of course, the real world isn't a perfect geometric drawing. It's messy. So how did this brilliant, but let's face it, pretty rigid theory get adapted to reflect actual reality? Well, another German economist named August Lösch came along and made Christaller's ideas way more flexible. He argued that the original model was too top-down. He proposed a bottom-up system where towns of the same size could actually specialize. You know, one might be a factory town, while another is a university town. He also allowed for tons of different overlapping market networks for all kinds of goods, each with its own k-value.
And the result of Lösch's model is a landscape that looks way more complex and, frankly, a lot more realistic. If you look at this diagram, instead of that perfect, uniform pattern, you see these weird, wedge-like sectors spreading out from the middle. Some are packed with towns, and some are pretty empty. These are what he called city-rich and city-poor sectors, and it's a pattern that many geographers think is a much better reflection of how real economic regions actually grow.
So you might be thinking, okay, cool theory from the 1930s based on some imaginary flat world, but what does it have to do with me today? Well, as it turns out, a lot.
Look, no place on Earth is a perfect flat plane. But the core logic of the theory gives us this incredibly powerful baseline for understanding why our towns and cities are arranged the way they are, even when things get distorted by mountains or history or the internet.
And you can literally see its principles in action. Planners in the Netherlands actually use these hexagonal patterns to build towns on newly reclaimed land. The super grid-like layout of the American Midwest on those vast, flat plains is another almost perfect example. And it's not just ancient history. Modern big data analysis in China shows these same hierarchical laws are still shaping its megacities. Urban planners today use this exact logic to find service deserts and figure out the absolute best place to build a new school or a hospital or a Target.
So at the end of the day, this theory isn't just some dusty idea in a textbook. Its logic has real, tangible applications that literally influence where you shop, the roads you drive on, and the economic policies that shape the very region you live in.
It reveals the invisible code that connects the tiniest village to the biggest metropolis, a timeless reason for how we organize our physical space. But what about our non-physical space?
And that leaves us with one last fascinating question. In our digital world, is Amazon a new kind of central place for shopping with a practically infinite range? Are social media sites new kinds of administrative hubs with their own rules and invisible borders? It seems the same geometric logic that Christaller discovered on the plains of Germany might be more relevant than ever, only this time it could be mapping the invisible landscapes of the internet.